Good day, my name is Martin Halliwell. I'm a professional engineer, civil, and an MBA. I've got 40 years of experience in special foundations, and I created the firm HCM, which is very successful today, and they are often called Innovation in Foundations. So what I want to do today is I want to talk about what I've been doing since I left HCM, and that is I've created approximately 11 patents. And those patents are systems, and they lower cost and lower schedule. And that's what owners want. They want to have a lower cost system, and they want to work with contractors who are honest. And my intention is to pick those contractors to represent my patents in the future. My company is called Footprint Engineering, and the iron ring that an engineer tends to get on graduation is suited with the FE, and then the Footprint Engineering. Sometimes I call my company FENG Systems or footprintengineering.ca, which is also got further illustrations of my patents. My patents are for sale in Canada and the US, although I do have one large firm as a second bidder that would bring additional revenue to our team. So this is a list of patents. As you can see, some of them are CA, Canada, and some of them are USA. And typically a patent will have a number that can be brought up, and the original write-up of the patent and the submission of the patent can be looked at. And my hope is that, well, I have a very good patent agent. I'd like to thank Ashley Burke and Neil Tannenbaum for all the work on trademarks. And I try to trademark things to create acronyms that are useful in the marketplace. So you'll hear some of those today, but they reference back to these numbers, and you can see down the left, there's the various trademarks, typically with an FE in front. This is one of my most interesting set of patents, and there's actually 3 patents shown here. So the vertical stem that's white is the geothermal, and we'll look at that in more detail as it enters the ground below. I have the most efficient geothermal in the world, and it runs on water, so it's clean. The solar panels you see there are from my patented solar snow melt curb. Works quite well. And the windmill can be done in 5 kilowatt and 10 kilowatt versions. We hope to put 2 full-scale windmills and geothermals of a significant size, one 5-ton and one 10-ton. So typically a geothermal would be mud drilled by a well drilling rig, go hundreds of feet, and my geothermal can achieve higher capacities, clean water use versus glycol loops, and a higher COP. COP is a return on energy of 5 versus the standard geothermal is 2.5. And the standard production of a ground loop system, they go 400 feet, 600 feet, is 1 day per hole. Whereas with a drill rig and a caisson drill rig, where my background is caissons, and some of my patents are piles and caisson related or geotechnical patents. And then I have the energy set of patents. So the windmill is attached to a geothermal, and the solar curb is in the same picture. There's 3 patents there. Protected for, there's another picture of the windmill. This is an internal design program of Fergoni Engineering, who's out of Boston. And he's one of our engineering associates that participates in the upside to the patents. So here's the FeBTU cell in a simplified version. And what we do is we take a different size internal pipes, but the pipe in the middle is actually full of water. So we use a water furnace and we pour a concrete plug. Some people would call this a pile. It's a geothermal pile. And that concrete below with a sealed pipe, that sealed pipe, large diameter, goes up and supports the windmill. So we're the only geothermal that has a windmill. And I often will call the pitchers and the windmill the ideal off-grid device. So what we want to do is we want to anticipate people's needs, company needs, and with all the things going on in society, AI and different things that require energy, we believe that our geothermal and our windmill is a unique set of patents. This is FeH2O lock. So this is a patent that was created to address in Toronto the tendency to specify what are called secant walls or drilled circles that interlock each other. It's quite expensive. And this is called a FeH2O lock, and this is a feather edge detail. So what I did was I put 2 5-inch layers of shotcrete, and I created a overlapping detail where it won't leak. So this is a waterproof wall detail, and it saves, I'll show you some of the savings sheets. I have one coming up shortly. It saves $100 a square foot. So there's the feather edge detail, which is actually the main claim. So when you do a patent, you often, Neil will ask me, what do you think the main claim is? So this feather edge cannot be copied because it's a main claim. It has more strength than the subclaims that describe the system, and I'll talk about some of those now. There's a picture, what we call plan view or elevation view, where the feather edges interlock. My company, Footprint Engineering, Inc. Next view. This is a view of one anchor. So when I created the company HCM, I created a system early on that could be done next to buildings rather than, they won't let lagging system, wood board lagging system next to buildings. And that's evolved to the point where anything like a building is circles or secant walls. And this is a bypass system, a double bypass, which I patented. And what happens is you create a composite action with the shotcrete by welding tabs on the pile. The pile is lighter because the composite action enables you to save volume or weight on the steel. Then we weld tabs on that, and this is a double bypass patented FeH2O lock. The anchor spigot, which is the pipe, allows me to put the second layer on and completely waterproof the wall. So with chem concrete, it's 95% waterproof. The interesting thing about that world patent, which isn't mine, but I cooperate with them, and I did a recent podcast. So if you go to the Contractors Innovation podcast, I had Jim Kaler, who I introduced to chem concrete. He's from Los Angeles. And Boris Nanuf, and it was quite a good podcast on chem concrete. I'm sure there'll be a part 2 to come. So here's just another further detail of the spigot. This is a 4.5-inch steel spigot, and you use a self-drilling bar. It's R38 or R51, and we also will do R63. And that's the hardware detail. So anybody in the construction industry would find this and ask the right questions. And I can be contacted at any time. So for anybody who's hearing this video, my mobile number is 519-240-6334. and my email is martinh@footprintengineering.ca. This is a triple anchor detail with 2 layers of 5-inch shotcrete. So you can see you can go almost to 80 or 100 feet deep would be the typical limit of excavation support systems, depending of course on what the strata is like. So if the rock is, in Toronto, a lot of layering goes down to the shale bedrock, but every city will be different, and every city in Canada has got different downtown conditions, and every city in the States. This is a detail with the double bypass on a lagging wall, so there's no reason you couldn't do this on a lagging wall. You can see the welded tabs. It would be more a case of doing that in less congested areas because they won't necessarily allow wood next to buildings, but this would have some applicability. Again, the W460. 460 is 18-inch, typically 18 at 55, which is as light as a soldier pile will get. Again, from the composite action of the 2 5-inch layers. This is actually a deal with any ground conditions moment. So in other words, if the building was stiffer or if there was a concern about movement of any type that I had, I could put a middle filler in, but you're cutting into some of the savings. It does have the drain board, so a mirror drain fabric, vertically continuous drain board, usually 1 foot to 2 feet wide is the typical detail for that. And you can see it here more clearly with the 18-inch vertical mirror drain, vertically continuous drain board. This is a low-cost product, and you're saving that repeated drilling. Now, the issue with secant walls is they almost always will leak. We could talk a little bit about that relative to the floors that go in front of these walls, but with a double bypass detail, this is actually the inside of the job. So the floor slabs, when they go by the 2 5-inch details, 2 5-inch layers, they end up supporting the floor slabs, and we can replace blindside waterproofing with these details using chem concrete and our feather edge main claim patent. That's a spigot. It's a pretty heavy device. I could have brought one here today and it would be noisy dropping it on the table. But there's the tabs, all the details, and I believe that would be on our website, footprintengineering.ca. This is actually a saving sheet. So what it shows is that over secant walls, you save $100 a square foot. And I think what a lot of developers want is savings. And what a lot of contractors do is they'll bid alternates. And so this FEH2O lock is an alternate over secant walls and saves $100 Canadian a square foot. This is FEGON 2.0. So like a lot of things, the earlier windmill picture we looked at, that was 1.0. And with 2.0, what I asked Fergoni Engineering to work on was we had to create a tighter system where we wouldn't get a vibration for the windmill. This is a connecting plate. We have a project called the Mushroom Farm coming up, and the Mushroom Farm will have 24-inch. This is actually less thickness than that, less diameter than that. Bolt circle. These are relatively common civil engineering and structural steel connections. This patent is called FEHD plank. So I had the opportunity to address the Pay Road in Toronto where they started being concerned about the life of a culvert. So what often happens with a culvert, CSP, corrugated section, that typically after the water runs at the bottom of the culvert for 15 or 20 years, you get a rusting of that bottom out. So they asked me, can you look at this problem and I came up with a system that involves 2 patents. So this is the first patent called FeHD plank. The planks are HDPE. They come 6 and 8-inch pre-curved. I adjusted the thickness on the first tests, and it works very well. And I would estimate that 6 men can do 100 feet a day. I have a fairly good understanding of labor and what it can do in a union environment. So good quality of men, like a Brian DeCudo, perhaps,
Yeah.
and maybe with a few jokes. I don't know how many people know Brian, but he's on our podcast. And he's the, I often call the Contractors Innovation Podcast a laugh and learn. So he provides a few laughs every time. The energy's quite good. This shows the, so the requirement that the 407 had was they wanted a 75-year life. They want 75 more years. So in order to model that, one of the best engineers I know, Matthew Janes, helped me with Plaxis, which is a finite element model. And the Plaxis was able to prove 75-year life with that finite element model. And that is similar to, so it's a 1/4-inch basaltic rope. We buy it from Meta Engineers in Windsor, high quality basaltic rope reinforcing. And in the install here, should be able to see this in subsequent pictures, the install is similar to a double Dutch skipping rope, if you remember as a kid. It's quite a nice patent. Neil actually said he'd like to just sell that. So I said, well, come work for us. This patent is very interesting. This is an FE combined modulus pile. And it reflects some of the history of doing drilled shafts in Toronto. When I was works manager for deep foundations in the 80s, and I think I managed to set up and run 1,000 jobs, including the Sky Dome at that time, with anchor shoring. And those companies today were bought up under a group called Green Infrastructure Partners, and we are talking to them. So this particular pile reflects clear stone at the bottom because they wouldn't allow, there was an unfortunate accident where somebody was knocked into the hole, and they stopped the practice of hand cleaning caissons that we did in the 80s. Sometimes markets can get too busy and people don't necessarily follow the right practices. There isn't, you always have to be visible by the operator. So in this, what I do is I auger clean the bottom, so it's usually shale bedrock, and then we put clear stone in, and we use the pipe to tap the clear stone, which is basically incompressible. I like 3/4 limestone clear stone. I've got it in several of my patents. It's incompressible. It tightens up, and then we have a shaft friction. So combined modulus means we use end bearing and shaft friction together. And it would be my recommendation that 1 out of 100 piles is load tested. That's a common specification for load tests. You don't test them all. So this is back to FeHD plank. You can see the finer details of the click system, and that's the 0.120 final version, and it's a slide and lock 6 and 8 inch, and I think we have 10 inch too. So there's another view of it. I think everyone would understand how that click flooring system works in the culvert. This is the double Dutch basaltic skipping rope. If you take any one of those patent numbers and know how to review the, you can review the details. So these details will be under those patent numbers that I showed earlier. Again, call me if you need any assistance getting the details off the actual patent. My windmill, to show, I call it the ideal off-grid device. And for a while I thought about just selling the drawings and giving people permission to use the patents. And that develops over time. It's been a number of years that I've thought about the best way to monetize what I've created. So my intention is to sell the Canadian and US patents and involve a second bidder in those markets through the encouragement of suggestions, and communication is key. I can wrap up now. My intention is to thank everybody for listening. We're going to be posting this on YouTube. FePatents by Martin Halliwell, 519-240-6334. My email is martinh@footprintengineering.ca. And I hope that this brings a project opportunity for you to call me and let me help you apply the patents in a safe and cost-effective way. So thanks again for letting me share this information today, and may God bless you.